If you were alive in the year 2013, you are in this photo, right here. This thing is Saturn, the sixth planet from the Sun, and the camera is Cassini. Cassini spent 13 years orbiting Saturn, and it took some of the best photos in the universe. Let's take a look. The first thing you probably noticed about Saturn is not the planet at all, but its rings. They are beautiful and expansive, but they're also thin, razor thin, anywhere from a kilometre right down to 10 metres. Let's say that Saturn is this tennis ball, about 66 millimetres. Then its rings are just a little thicker than a strand of DNA, but as wide as an extra Saturn on each side. Now, Saturn is not as spherical as this ball, it's actually squished 10% smaller pole to pole than through the equator. So the rings are thin, but they also hide a lot of secrets, from the dance of Saturn's churning core to the very building blocks of life. What makes a ring? Well, for Saturn, the answer is almost entirely water ice with a sprinkle of rocks and dust. These ingredients make sense because we think the rings are the scattered remains of two icy moons whose massive collision totally restructured the orbit around Saturn. We don't think that collision happened that long ago either, less than 100 million years. If dinosaurs had had telescopes, the rings wouldn't have been there. And they won't stick around that long either. So-called ring rain is constantly pouring down on Saturn, and if it holds steady, the rings could be gone in less than 100 million years. But lucky for us, the rings are here now, so let's investigate. We'll start just 70,000 kilometers from Saturn's core with the innermost D ring. This ring is faint. In fact, it wasn't confirmed until the Voyager missions in the early 1980s. But when Cassini revisited, it found the D-ring had changed, moving inward, diffusing, and revealing fine structure. Moving outwards, and the C, B, and A rings are the most familiar to us. These are the ones you can see in an average telescope. The C ring, which is shiny and see-through, gives us a record of Saturn's churning interior. Gravity shifts from inside the planet leave notes on the C ring, like sheet music, which scientists can read to better understand the giant planet's core. Moving out to the B ring, and the fine structure you see here surprised scientists who still don't know exactly what causes it. By the way, these scratches aren't part of the ring at all, but come from cosmic rays bouncing through Cassini's wide-angle camera. Next, there's a curious gap, but it's not actually empty. 4,800 kilometers divide the A and B rings in a space known as the Cassini division, named not after the spacecraft, but after the astronomer who discovered them in 1675. The outer A ring has these spiral density waves, which are not lots of rings, but a handful, tightly wound together in spirals. The A ring also hosts our first shepherd moons, Daphnis, whose gravity cuts ring waves from within the 250 kilometer Keeler gap, and Pan from the Encke gap. Now, a shepherd moon is pretty much exactly what it sounds like. These tiny moons clear gaps in the rings, deflecting particles from their gravity or orbital resonance. We find more shepherd moons in the much more chaotic F ring. Its larger shepherd, Prometheus, kicks ring matter up every 14.7 hours, creating these distinct slanting lines. The G ring comes next, and it is weird. These strange, bright arcs light up the rings regularly. Scientists believe they're long-lived and caused by the moon Mimas, which looks uncannily like a certain weapon of mass destruction from a famous sci-fi franchise. We've reached the outer edges of Saturn's ring system, but find ourselves at the weirdest one yet. The E ring doesn't look anything like the others. It's puffy and kind of misty, which makes sense because it's from an ocean. specifically the ocean of Enceladus. This tiny ice moon is just 500 kilometers across and on the face of it looks a lot like every other moon around here. But it's not. Beneath its icy crust lies a potentially global liquid water ocean melted by gravitational energy. Ocean moons like this are a boon in the search for life, but Enceladus holds one more trick up its sleeve. It's venting that ocean, non-stop, at 400 kilometers a second from its south pole. They're called the tiger stripes, and their plumes stretch 10,000 kilometers into space, supplying ever more material for that misty E-ring. But it gets better. Cassini flew through the plumes, and what it found was really interesting for astrobiologists. We typically think of life as needing chnops: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Cassini initially found evidence for all but one of these in one form or another, but in 2023, scientists found phosphorus in the E-ring. This is a building block of DNA and a really good sign. When you add in findings of methane and the ingredients for amino acids, you have a really exciting discovery that warrants further investigation. At this point, you should probably know that Cassini did not come to Saturn alone. It brought a sidekick thanks to the European Space Agency, Huygens. Huygens had a very different mission and a different target, one of Saturn's moons, Titan. Titan is unique in our solar system. It's the only moon with an atmosphere and the only other world with liquid surface lakes, but not as we know them. Titan is cold, minus 179 degrees cold. At these temperatures, the icy surface is as hard as rock. The liquid then isn't water at all, but hydrocarbons, stretches of polished, smooth methane and ethane. Huygens detached from Cassini and flew through Titan's atmosphere in 2005. That atmosphere is thick, almost 50% thicker than Earth's, with lower smog that blocks out almost all visible light. This video visualizes the probe's descent, and this is what Huygens saw at the surface. Back in Saturn's orbit, Cassini kept going well beyond its scheduled 4-year mission lifetime. In 2013 came one of its most ambitious actions, that beautiful mosaic we saw a peek of at the start of the video. This image is comprised of 141 wide-angle images and includes not just 7 billion humans, but Mars, Venus, and a smattering of Saturn's beautiful moons. Cassini finally said goodbye to Saturn with a grand finale, a fatal plunge of 22 orbits inside the planet's rings, speeding along at up to 126,000 kilometers an hour. As a final act of scientific sacrifice, Cassini returned priceless data on Saturn's atmosphere before burning up in fiery glory. Now, Saturn stands alone, having devoured humanity's singular outpost to the 6th planet. New missions are planned, like the Titan Dragonfly, which hopes to achieve our first powered flight on a moon in search of the building blocks of life. A dedicated mission to Enceladus will hopefully follow. But until then, we can rejoice in the weird and wonderful art created by a spacecraft that defied the odds and brought us closer than ever to the most beautifully accessorized planet in the solar system. Hey, it's been a while, but I'm really happy to be back. Thank you so much for watching, and let me know in the comments what your favorite thing about Saturn is. If you enjoyed the video, please like, share, and subscribe. It really helps out. Thanks again for your support, and I'll see you next time.